Good day everyone, welcome to another wonderful tutorial class on evaluation physics. My name is Mr. Duro, your evaluation physics instructor. Based on popular demand, I'll be taking you through refraction of light through lenses today. I'm going to show you the ray diagram of how light enters through the lens and is being refracted on the other side. But before I proceed, let's start with the definition of a lens. What is a lens? A lens is any transparent medium or transparent material that has at least one side of the surface curved. There are different types of lenses, but that is not going to be discussed in this class. Our focus, like I said, on this class is refraction through lenses. The ray diagram, how the light enters the lens, and also how it is refracted to the other side. So, we're going to use a case study of a converging lens, or what some people call biconvex lens. It looks like this. Let's draw the first line that passes through the axis. On this principal axis, we have two focal points. One here, and the second one happens to be 2F. It's my interest to know that the distance between this center, which is referred to as the optical center of the lens and this place, is 2 times the distance between this place and 2F. So for instance, if F is 10 centimeters, what that means is that the distance between C and 2F is 2 times 10, which is what? 20 centimeters. But that is not our interest in this class. On this side of the surface, we have an F and a 2F. On the other side, we also have a focal point and another focal point that is equidistant from the first one. We differentiate these two by putting a prime on this and on this, depending on wherever your object lies. So for instance, let's assume that an object is placed at this position here. The image automatically will be formed on this side of the lens. And I told you at the beginning of this class that a lens is any transparent material that has at least a surface curved. But in this case, where you have a biconvex lens, it has 2 surfaces that are curved, and both of those surfaces are useful. Either of them can serve as the object space and also as the image space, depending on the position of the object. If the object is placed here, then the image will be formed on this side. If the object is placed here, then the image is formed on this side. But for the instance of this class, the object is actually at this distance and on this side of the lens. Now, there are 2 basic rays that you're going to draw in order to obtain the image formed by a lens. The first one is a ray that passes through the head of the object and the optical center of the lens and goes through without being deviated. So all you need to do is to get a ruler, join the head of this object to the center of this lens, and you draw. The other one is a ray of light which passes through the head. When it gets to the center of the lens, it is refracted and it passes through the focal point at the other end. That is the second ray diagram. Where those 2 rays converge, where they meet, is the point where the head of the image is formed. And from there, you can project and get your image. So let's do the second diagram. The first one again is from the head through the optical center. A line is drawn to join those 2 points together and a cut across the lens to the other side. The other line is the line that is drawn parallel to the principal axis, meets the lens at this point, and it converges through this point F to the other side. You will see that the first ray and the second ray both converge at this point. That is going to form the head of the image. And from there, you project it down to the principal axis again to join this one. and automatically an image is formed. And from this, you can deduce the nature of the image formed. Based on this image diagram, number one, the image is inverted. Number two, the image is magnified. As you can see, it is actually bigger than the size of the object. And number three, the image is real. Real in the sense that the image can actually be caught on a screen. Now, assuming this was a lens, a practical lens, and an object is placed there, if I put a screen or a paper at this end, that image will be formed on that paper. So let me recapitulate in order for us to get the explanation correctly. Like I said, if the object is placed on this side, there are two rays that will be drawn. The first one goes through the head of the object, through the optical center, a straight line joining the 2 points together, and is projected to the other end of the lens. The second one is a ray parallel to the principal axis, coming to join the lens at this point, and is refracted after this point through the focal point. Don't forget, focal point is the point at which all rays tends to converge after refraction. And that is why it is passing through this point. And where these two rays meet, where they converge, we form the tip or the head of the object that we are considering. And that is projected to the principal axis again. And from there we can deduce that the final image is inverted, it is magnified, and it is real. You can have a practice of this by putting this object in various positions along this principal axis. It could be at 2F and it could be beyond 2F. Do that at the practice and hit me up on my WhatsApp number 08060438946. Any questions involving physics or evaluation physics can be pushed across to me and be sure you get the best of service. Many thanks for listening. Have a wonderful day. Thank you. Bye-bye.